when you check?
So when I use the tool to check the normality, the tool the result is the data sets follow the normal distribution.
So what method did you use to check? What method did you use?
Actually, I use the tools to check, and it show me the box plot, the Shapiro wheel test.
Okay. You use the software to check?
Yes, on the Excel.
Okay, Excel. Good.
Yeah.
Okay. So you have the box plot. Okay. What else?
The Shapiro wheel test.
Okay. Test. Okay.
And it also has the Agostino-Pearson test.
So what is the result?
The result of.
Okay. Can you share your screen when you check? Can you share it?
Yes, let me share.
Okay, I should stop my screen. Should I need to stop?
Yes, you can stop your screen.
Yeah, you share the screen so that your friend can learn something from you.
Can you see my screen?
Yes, you can see. Yes.
So this is my normality test. I have the box plot here.
Okay, so can you describe about the box plot?
Yeah, so the box plots have a 5 value, the mean value. Mean here. The mean value here, the Q1 value, the median, and the Q3, and the maximum value.
Okay, how did you get the table of value mean Q1, Q2, Q3? How did you get this?
I don't know. I use the tool and they do it for me. So I.
Can you explain how?
I just use the tool, so I don't really understand how they give me the result. Maybe
you use a tool?
Yes.
What tool did you use?
I use this one, the real statistic tool.
Okay.
Yeah.
And in this one?
Yeah. So I see the box plot, the mean values is at the middle of the box.
Okay. The medium or the mean?
The
line in the box. What is it? The middle line in the box. What is it?
I think is median. Yes. So the line is the median.
Okay. Yes. The middle line is the median. Okay.
Yes.
So you see. So how can you say that it is a normal distribution?
So my mean values is near at the middle of the box.
The mean or the medium?
The median value is at the
median. Yes, the median
of the box.
Yes, it's nearly is. Yes. Okay.
Yeah, we conclude it follow the normal distribution.
Okay. Yeah. Continue.
Yes. So after I have the conclude that my data sets follow the normal distribution. I will use the parametric test to I will use the parametric test to see if the And then I will set the hypothesis. The next part I write down in my notebook, but not in the Excels. So I think I can stop my screening. Can you show us the
Okay, yeah, I show again the lecture.
Yes.
Okay. Okay, yeah, so you already checked assumption first, so you can conclude that it follows the normal distribution. So you can use the parametric test, that's correct. Okay, so continue to explain how can you solve this exercise.
Yes. For part A, I will set the hypothesis, the null hypothesis. My null hypothesis is a new machine will pack slower or equal on the average than the old machine.
Yeah. Yes.
Yeah. So
The example, right?
Yeah.
Okay.
My alternate hypothesis is the new machine will pack faster on the average than the old machine. Then I found the V1, V2, the variance, and I calculate the T star, and my result is minus 3.39. It is approximately minus 3.4. And because my T start value is smaller than 0, so my rejected region will at the left side of the graph. And I have the alpha values equal to 0.05. I will look, and the DF, my degree of freedom is 18. I will look at the T table. I will look at the T table and find out the T grid is equal to minus 1.7341.
Okay.
And the T start will smaller than the T start value will smaller than the T grid value, and I will reject the null hypothesis.
Yeah.
So it means the new machine will pack faster than the old machine.
Yeah. Okay. But you like to explain, because we have two types of t-test, right?
So because the sample size is smaller than 30, so I will choose the t-test. Is that correct?
No. Can you show how many kinds of t-tests? You remember we have two types of t-test: independent t-test and paired t-test, right? Independent and paired t-test.
Yes.
You remember that?
Yeah. So it means I have to detect the variable is independent or dependent.
Yes. You need to explain. Okay, what kinds of t-tests you will apply in this exercise?
I will apply the independent t-test.
Why?
Because we have the independent variable.
Yeah, we had independent, yes, variables, yes. What is a variable here? What is a variable here?
The new machine and old machine.
Is it correct? Is it correct?
Or the packing time of new machine and old machine.
Yeah, the packing time. Okay, so packing time is an unvariable, and what you check for the normal distribution here is the variable packing time. Follow the normal distribution, not new machine or old machine follow normal distribution. Okay, the variable, the dependent variable here is the packing time, and the machine you use, that is a independent variable, okay? And it is a categorical nominal variable, right?
Yes.
Yeah, because it has 2 times our new machine, okay? And it's categorical variable, nominal variable. And the dependent variable in this case is a packing time. Yes. It is a ratio or interval.
Exact ratio.
Yeah, it's ratio variable. Yes. And because this variable is a independent, so we applied the independent sample t-test. Okay. Yeah. So in general, you did well this exercise. It's like the explanation of the independent t-test. Okay.
Yes.
Yeah. So thank you. So now I show you. Yeah. Here. So for this exercise, firstly you can check normal distribution first, or you can check assumption about the independent sample first. We want to apply the independent sample t-test, so we have 2 assumptions that we need to check. This is assumption about the independent sample. Yes, the variable here is independent. And as Ha Se-Yu, she used a box plot in the Excel, or she used a statistic test, okay, and it shows you that the variable follows the normal distribution. Okay, here I give you the result of box plot. We have several methods to check the normal distribution, okay, and you can apply any of them. And here is a box plot, okay. So if you look at this box plot, what can you explain? Trần Nam Khang, are you there? Okay.
Yes.
So if you look at this box plot, can you explain about the normal distribution?
Yes. So I mean, this is the first one. The left hand, they are in the same line, so it should be the normal distribution. While the second one, the below and the top dot is just out of the line, so it's just not the normal distribution.
Okay, so what is the variable that you need to check about the normal distribution here? What is the variable?
Maybe in a bit.
We talked about it already. I told you already.
Yes, but let me take a look at my notes.
Okay,
It's just
what variable that you need to check if it follows the normal distribution or not here.
Yes.
What variable that we have
to check the normal mean and median. So if the mean and median are nearly equal, so the value is follow the normal distribution.
Yeah, so do you understand my question? I'm asking you what variable here? What variable you are checking for the normal distribution? Do you understand about the variable?
Packing time.
Yes, packing time, okay? That is a ratio variable, independent variable in this exercise. And you need to check the packing time follows the normal distribution or not, okay? And here is a box plot of the packing time of 2 methods. The method 1 using the new machine, and the method 2 using the old machine, okay? And if you look at this box plot, what can you say?
The 2 groups are the value of 2 groups and normal distribution.
Why?
Because on the dot here is on the line.
Or on the line, close to the line, okay? Not really on, but they are close to the line, so we can assume that they follow the normal distribution, okay? Yeah. And so after you check the two assumptions of independent sample t-test, we will write, oh, there is another assumption that I also forgot it, that is about the variance. Okay? Because we will have the computation for the same variance or unequal variance. Okay, so you need to check about the variances too. So in this case, because we already have all the data, you have the packing time for new machine, you have the packing time for old machine, you have the data. So you can calculate. It's important for you to calculate the mean, okay? The mean and the variance. S is a standard deviation, S square is a variance, okay? So you need to calculate the variance. Here I gave you already the variance, S1 and S2, okay? So we need to check for the assumption about the variance. The two groups have the same variance or not, okay? Here they have the same sample size already. They have the same sample size. And now we have to check if they have the same variances or not. And if you look here, the variance you can calculate directly from the data, and you can see that they are nearly the same. Okay, we can make assumption that the two groups have the same variances. Okay, the rule of thumb to assume for the same variance is at 1 over S2. The ratio is between 0.5 to 2. Okay, if this ratio in this range, we can assume that the two groups have the same variance, and this is the case. So we can assume that the old machine and the new machine group, they have the same variances. Okay, so there are three assumptions that you have to check for the independent sample t-test. Remember that. And then, okay.
Cô ơi, em hỏi một chút ạ. Khi mà mình làm bài để trình bày bài thì cái đoạn assumption on cái sample independent ấy thì mình cần viết như thế nào ạ?
Thì em phải giải thích là hai cái mẫu đấy là independent hay là không.
Chỉ cần viết thế thôi ạ? Không cần phải thêm nữa.
Em ví dụ nếu như nó pair thì em nói cụ thể trong cái bài của mình ấy. Là như thế nào đấy, thì cho nên là nó là pair hay là nó là independent, tức là đưa cái case của mình ra nhá.
Ok ạ.
Thế với t-test thì bao giờ nguyên tắc chung là mình phải thỏa mãn ra cái assumption đấy để mình dùng được independent sample t-test. Ok, bình thường các bạn khi mà làm đề tài thì các bạn cứ bịp vào làm chứ thực không hiểu bản chất, hiểu chưa? Thực ra nguyên tắc là phải đảm bảo những assumption này thì mới được sử dụng, còn các bạn theo thói quen cứ thế dùng thôi, chả cần biết đúng sai, đúng không? Dạ. Ok.
Hôm nay con đang ở trường với mẹ. Con đang ở trường với mẹ của con ạ.
Okay, so okay, so and then you need to write down the non-hypothesis and the alternative hypothesis. So to write down this, you need to look at the question. Okay, so our question, I back to the question here. Can you conclude that the new machine packs faster? So in this data set, we have the packing time. So if the new machine packs faster, it means the packing time of the new machine is less than is less than the old machine. Okay, so it means V1 minus V2 less than 0. So what we want to conclude will be the HI, the alternative hypothesis. Okay, so H0 will be against the HI.
Con đang ở trường chạy con ạ.
Okay, so you write down the H0 and HI like I showed you on the slide. So for most of the cases, the alpha will be 0.05. If I don't give you, you will assume that it's 0.05. Okay. So here I give you already the significance level is 0.05. So you will apply the t statistic. You need to compute the t statistic. Apply the computation 1. Okay, we have the computation 1 already, so you just apply it. You can easily get this one. It's not difficult, this kind of exercise, but it is easy to get wrong results if you are not careful in calculation. Okay, so I already gave the correct result about the p-value. Okay, here is a minus 3.4. And after calculating the p-value, you need to show the redirection region and non-redirection region. Nguyễn Thị Linh, are you there? Nguyễn Thị Linh.
Yes. Yes.
Can you tell me this is a one sample t-test or one tail or two tails test?
It is one tail test.
One tail test. Why? Can you explain why it's one tail?
The question is whether the new machine is faster than the old machine. It's just one side.
Can you explain more clearly? Last time I told you already the technique to determine that it's a one tail or two tail. We will look at, yes, we will look at the question, and the question is described in the HI hypothesis, right?
Yes.
Yeah, so we look at the HI. H0 and HI, we look at this. We are trying to test the H0 to see that we can redirect H0 or not. So we will think what values can redirect H0. What value can redirect H0?
When the t value is greater than the t critical value, then we can replace the H0.
Yeah, it's correct, but it's the later step, not directly to answer this question. So the H0 here is a V1 minus V2 is higher or equal to 0. Okay? So it means the low values less than 0 will redirect H0, right? So if V1 minus V2 less than 0, the low value will redirect H0. When V1 minus V2 is less than 0, we will rewrite the H0, right?
Yes.
Yeah. So it is a one tail because only the small value can redirect the H0. Okay? So to determine that is one tail or two tail, we will look at the H0 and we ask the question, what kinds of values will redirect the H0? And in this case, because the H0 is V1 minus V2 higher than 0, so the low value less than 0, for example, will redirect H0. So it means just one tail, only the low value can redirect H0. So this answer also helps you to determine the redirection region, the low value. So the redirection region will be on the left okay, the negative value on the left of the T critical. You understand what I mean?
Yes.
Okay, anyone don't understand how to determine one tail or two tail? This step will help you to determine the redirection rerun too, not only one tail or two tail, but it also helps you to determine the redirection rerun will be on the left, on the right, or two reruns. One tail test, it means only one redirection rerun. Two tail test, it means there are two redirection reruns, okay? If it's one tail test, there is only one redirection rerun, but we need to continue to determine the redirection rerun will be on the left or on the right, okay? To know that, we will answer what values will redirect at 0. In this case, the low value less than 0 is mu1 minus mu2. If it's less than 0, it will redirect at 0. So it means only the low value can redirect at 0. So the low value will be on the left. So the redirection rerun will be on the left. That is the way to think about the redirection rerun and the one tail or two tails. Okay, so this case is the one tail test, and the redirection rerun will be on the left, will be the low value. So if T values T calculated less than the T critical, we will redirect the SRO. Okay, so how to determine the T critical? Định sao Mai? Exactly.
The T table in the table that you sent us is the table E, and the degree of freedom is 18.
How to know the
alpha-
degree of freedom?
The degree of freedom, we use the sample size of the sample size of new machine plus the sample size of the old machine, and we
Yes.
minus 2.
Yes. Okay.
Yeah, and we get
So
18.
10 plus 10. Okay. 18. Yeah. Continue.
Yeah, and we look at the T table. Here we are the one tail, so the rejection zone will be on one side.
Yes. All right.
Yeah, and we use the whole alpha value is 0.05.
Yes.
Yeah, and we look at the line of the degree of freedom of 18, and I found that the value is
So we will look at the
1.7.
column. The column is a T9
95.
995, right?
Yeah.
Okay. Yeah. And DS 18, right?
Yes.
Okay. All right. Okay. Yes. So the step 4 is to find out the critical value. This is also really important. To find out the critical value, you need to know it's one tail or two tail. Okay, and this guy is one tail. So if it is a one tail test, you need to know it is the left or the right tail. And I explained you already to know it's left tail test or the right tail test. You will look at the H0 and answer the question, what values will redirect H0? And in this case, the low value mu1 minus mu2 less than 0, the low value will be redirect H0, so it is on the left. The low value will be on the left, the high values will be on the right. Okay, so in this case, the low values will redirect H0. So it is a left tail test. And equal is the one tail, so it is the T alpha will use the column T1 minus alpha, okay? T995 and DF is 18. We will find out the critical value is minus 1734. Okay, because it's a left tail, so the critical value will be the minus the negative value, and the redirection rhythm will be calculated less than the t critical. And you can write down, you can draw this curve. You should draw the curve so that you can imagine it better. Okay, you can look clearly the redirection rhythm. Redirection rhythm is a red rhythm on the curve on the left of the T critical. Okay, if it's a left tail, the T critical will be the minus value. If it's the right tail, the critical will be the positive value. Okay, and you compare the T calculated with the T critical, and in this case you see that the T calculated minus 3.4 is less than the T critical. It is in the redirection rhythm, so we redirect CH0. At alpha, the significant level is 0.05. Okay, so you can conclude that you redirect CH0. Đỗ Bích Ngọc, can you say? Đỗ Bích Ngọc.
I'm here.
Okay, so what can you conclude?
What can you repeat the question?
What can you conclude?
Here is so the null hypothesis. We determine at the beginning that the new machine have lower than old machine. So here if the t value is lower than the T critical, so we reject the SO. That means the new machine is faster than the old machine.
Yeah. We reject S0, it means we accept SI. Okay, so the SI is accepted. So SI is what we want to, what we hope, what is asked in the question. SI is what we hope. So finally, so what we conclude is correct. So we need to write down the conclusion in words. At 5% level of significance, it means when alpha is 0.05, okay, the level of significance is 5%. The data provides sufficient evidence that the new machine is faster than the old machine on average. Okay, so finally you will write out the conclusion, and it's very important when you report the data. Okay, you need to give the conclusion about the data for the readers. And you need to write correctly. So if you understand well the statistics, okay, so you can write down, you can interpret inference the data well. Okay, so I give you an example about the independent sample t-test, and I give you very clear here the solution for this kind of example, so that you know how to do with this kind of exercise. And so it also helps you how to analyze the data in the future when you do research. When you have such kind of data, you can analyze the data better. Okay, you understand more intensively what you are doing with it. Not only you run the test on the software, but you don't understand why you use it. Okay, how do they work? Yeah, you can continue with this. Continue with this question.
Cô ơi, cho em hỏi cái công thức T cô vừa show trong bài là cô dùng công thức 2, thì em tưởng là cái này phải dùng tính T là dùng công thức số 1 chứ ạ?
Công thức cô vừa show á?
Vâng, cái tính T ạ.
Cô check lại nha. Check lại công thức. Công thức ở đâu? Đây là cái tính T. Công thức này là công thức mấy?
Công thức
Cô,
1.
cô có dùng kênh này không?
Không, cô dùng công thức sau.
Cô dùng công thức sau á?
Vâng,
Cái này á?
Vâng.
Có đúng không? Nhìn lại cho kỹ xem nào. Nhìn lại công thức cô vừa dùng nào. HP. Công thức 2 là khi nào? Công thức 1 là khi nào? Đây là công thức 1. Công thức 2.
Công thức 2 là khác sample size ạ.
Công thức 2 khác sample size, công thức 1 là cùng sample size. Thế cô đang dùng trong bài này là công thức gì?
Đây công thức 1.
Công thức 1 mà.
Thật em thấy em nhìn ra công thức 2.
Rồi. Cô đang dùng công thức 1 đúng mà, phải không? FP1 sinh hoạt.
Tại sao lại có trừ không ở đấy hả cô?
Trừ không ở đâu hả em?
Ở cạnh cái tx1 trừ x2 xong rồi đóng ở ngoặc trừ không.
À, tại vì mình đang so sánh với không. Đây này, giả thiết H0 là mi1 trừ mi2 lớn hơn bằng 0 được chưa? Giờ chúng ta đang so sánh cái hiệu hai cái min này với 0. Nên là phải trừ 0 trong công thức tính t value ấy. Nếu mà so sánh nó với một giá trị gì đấy thì sẽ trừ cái giá, ví dụ là mi1 trừ mi2 lớn hơn bằng 54 chẳng hạn. Ví dụ vậy thì sẽ phải trừ 54 ở đây. Đấy là công thức chung mà.
Dạ vâng, ok. Tại vì em lại hiểu là so sánh hai cái min này với nhau nên là
So sánh hai min về này với nhau và thì chính là so sánh với không.
vâng ạ.
Được chưa?
Ok ạ.
Ok nhá, bây giờ các em làm tiếp cái câu này đi. Confidence interval. Bùi Bích Ngọc.
Yes,
Okay, can you give me the result?
the alpha in this case is 1%.
Yes, alpha is 1%. So it is a 0.01, right?
Yes,
Okay. So continue to
and we set the hypothesis.
calculate
Is 100% minus 99%.
you are calculating what?
100% minus 99% equal 1% is alpha.
Okay, alpha is a 0.01. Okay, I agree with you. Okay, do you know the formula to calculate confidence interval? Do you know?
No, I don't know the formula.
Oh, you don't know? So how can you do this exercise if you don't know the formula? Hồ Minh Nguyệt.
Teacher, sorry, I don't do this. I don't.
You don't know how to do this?
No, sorry, I don't finish this.
You don't finish? Đặng Hoàng Hiệp. Đặng Hoàng Nghiệp.
I'm still checking the result.
Do you know the formula to calculate confidence interval? Do you know?
Yes. I am checking if I calculate it correctly.
Huân Anh, can you do it?
I finished the calculation. Can I talk?
Okay, yeah.
So the formula to calculate the confidence interval is x1 bar minus x2 bar plus or minus the t-value of alpha divided for 2 multiply for SP multiply square root of 1 over sample size and 1 plus 1 over n2. Is that correct? Teacher.
Oh yes, it's correct, Huân Anh. The formula you gave me is correct. So the first step is you need to find out the correct formula for confidence interval. Yes. Continue, please.
Yes, so I calculate with the formula and I came to the final result is an interval from minus 2.01 minus 2.01 to 0.17.
To 0.17?
Yes.
So it means from negative to positive value? The
yes.
Interval?
Yes.
Are you sure? I think you should check it again, the result.
Okay, let me check it.
Okay. What is the T alpha over 2? What is the value of T alpha over 2?
The T alpha over 2 is 2.8784.
Well, how can you got it?
The alpha is equal 001, so alpha that divided for 2 is 0.005, so we need to look at the column of T995.
Okay. And DF?
18.
DF is 18, yes, correct. Yes. So check again the result, okay? The formula is correct. Confidence interval. Yeah.
So it should be between minus 0.167 and minus 2.013.
Oh, it's very different from 19.
Yes, I think so. That's why I'm checking.
Yeah. So you see, with this kind of exercise, it seems to be easy, but you may got very different results. So, preparing for the exam, it's not easy to get the high mark for this kind of exercise. Even it's very easy. Be careful with this calculation. Did you use the same formula for confidence interval like for 9 here? Did you agree with? Yep. Yes. Did you use the same formula as when I did?
Yes, I use the same.
Oh, so why you got so very different? Phạm Ngọc Hà, did you get the result?
If I have the same formula with Vân Anh and Hiệp, and I just found the SP is equal to 0.7173.
Okay, that is the SP.
Yes.
0.717, yes, is correct. So what is the interval that you got?
I got the interval from the minus 2.02 to
Yes.
minus 0.177.
Yeah, yes, it's correct. Yes, thank you. Bùi Đức Huy, did you get the same? Huy,
Yes.
you get the same with her?
Well, as my calculation, I got it from minus 0.167 to minus 1.371.
1.3, a bit different.
71. Yeah.
Yes, okay. Okay, so I show you here, that is a solution for this exercise. Okay, so the first step, you know here, we are going to calculate 99% confidence interval. So it means the significance level alpha is 1 minus 0.99, okay? So it's 0.01. You agree with me that one? Okay? So the formula for calculating the confidence interval is x1 bar minus x2 bar plus or minus t alpha over 2 sp and square root of 1 over n1 plus 1 over n2. That is formula for confidence interval. And you need to determine t alpha over 2. Okay, so t alpha over 2 is the t 0.005, which the df, the degree of freedom, is 18. Okay, you can easily determine this one from the the table table statistic as the column D995. Okay, and the DF 18. So you can find the T alpha over 2 is a 2.878. Okay, and you apply this formula, and the confidence interval will be between minus 2.01 to minus 0.70. Okay, so what is your comments about this interval? From this interval, what is your comment? If you look at this interval, các bạn có biết trong tiếng Việt gọi cái này là cái gì không? Khoảng gì đấy?
Khoảng tin cậy.
Khoảng tin cậy nghĩa là gì? Là 99% khoảng tin cậy nghĩa là gì? 99% khoảng tin cậy. Đề hài nhá, quay lại đề bài hỏi tìm cái gì đây? Đề bài hỏi là gì? Tính 99% khoảng tin cậy cho sự khác biệt giữa thời trung bình về mặt thời gian trung bình giữa cái việc dùng cái máy cũ, máy mới và máy cũ. Được chưa? Như vậy chúng ta đang tìm xem cái thời gian trung bình khi sử dụng máy mới và máy cũ thì cái sự khác biệt đó là bao nhiêu. Được chưa? Chúng ta đang ước lượng, đây là một cái khoảng ước lượng cho sự khác biệt về mặt thời gian trung bình khi dùng máy mới và máy cũ là bao nhiêu, với mức tin cậy là alpha bằng 0,01. Tức là gì? Tức là niềm tin của chúng ta, cái độ đúng của nó là 99%. Vậy thì khi mà chúng ta tính được cái khoảng như thế này thì nghĩa là gì? 99% chúng ta tin tưởng chắc chắn rằng là gì? Cái sự khác biệt về mặt thời gian trung bình giữa hai cái nhóm khoảng từ âm 2,01 đến âm 0,17. Như vậy là hai cái này sẽ mấy 1 trừ 2 sẽ đóng hiệu số từ sẽ nằm trong khoảng âm 2 đến 1. Cái khoảng này là giá trị dương đấy. Khoảng này là chứa giá trị những năng ngọc thì
Yes, I'm here. Yes, I'm here. Sorry, teacher, I cannot hear you. Sorry, teacher, I cannot hear you quickly.
Teacher, the signal from your side is poor.
Can you hear me now?
Yes. Yes.
Okay, I've lost my internet. Okay, sorry for that. Trần Ánh Xuân, can you hear me?
Yes.
Okay, so can you explain about this confidence interval beyond minus V2?
So depend.
So you see here beyond minus V2 is between. We are 99% confidence that beyond minus V2 is between minus 2.01 and minus 0.17. So you see from this interval that beyond minus V2 is less than 0, right? So
Yes.
from this interval you can know that mu1 minus mu2 always less than 0. Okay?
Yes.
So the first thing you can know is that mu1 is minus mu2 is never 0. It's never be 0. So it means mu1 is not the same as mu2. Okay? So mu1 is different from mu2. So these two types of machines will patch differently. That is one conclusion that you can say about the two machines. And the second one is here. You not only know that mu1 is different from mu2, but you also know that mu1 minus mu2 is less than 0. So it means that mu1 is less than mu2. mu1 is the mean time packing of new machine, and mu2 is the mean packing time of old machine. mu1 less than mu2, it means the new machine packs faster than the old machine. Okay, so from this confidence interval, you also can conclude that the new machine packs faster than the old machine. Okay, you can rewrite the H0. mu1 minus mu2 is less than 0. Okay, so you can rewrite the H0 and accept HA. So that is the second way that you can test the hypothesis using the confidence interval. The first way is to find out the redirection region and non-redirection region, calculated the t-value. That is the first method that we did. And confidence interval is the second method that you can apply to test the hypothesis. Okay. Okay, so you got it. You understand how to calculate the confidence interval and how to interpret the confidence interval and apply it to test the hypothesis and make conclusion. Okay. So we take a break. We take a break and then we continue. So we have already talked about the independent sample. And now we will sample t-test, and now we move to the pair t-test. Okay, so in t-test you remember that we have two types. One is independent and the other is a pair t-test. Okay, so you need to differentiate very well between these two, and you need to know the assumptions before you want to use a t-test. Okay, so I ask once again if you remember. Nguyễn Hoàng Anh Quân Anh, sorry. Nguyễn Hoàng Quân Anh.
Yes.
Can you tell me again what is the assumptions that you need to check if you want to do an independent sample t-test?
First one is to check if the sample independent sample.
Okay.
The second one is to check the normality.
Yes. Okay.
And the third one is check the sample variant.
The sample variant. Yes. Okay. Thank you. Nguyễn Phương Anh, are you here today? Nguyễn Phương Anh?
Yes, I'm here.
Okay. So when will you use a paired t-test?
We will use the pair t-test to compare the means of the same groups.
So we will use a pair t-test when the samples are paired sample, okay? Paired data, not independent data, like the case for independent t-test. We can say that is a repeated measure or matched samples. And normally you will see the case for pre and post test for the same people. Many cases is like that. For the same people or the same object or the same thing, there is a data pre, means before and post test or after the test, okay? Pre and post test. So that is a very common example of the, you say, the matched data or the paired data, okay? So the object 1, sample 1 and sample 2, that is a sample 1 is a before the test and sample 2 is after the test. So we have many pairs, different pairs of data of different objects. So in this kind of test, to test the hypothesis, you need to calculate the difference between each pair. That is for the pair 1, you calculate the difference. That is D1, sample 1 minus sample 2. For example, you take the value of sample 1 minus the values of sample 2. In the same pair, you will get the difference. So you will get the new data set, D1, D2 until Dn. The n is the number of objects or the sample size, okay? The small n here, that is the sample size. And we will work on this data set, D1 to Dn. The differences between data in each pair. Okay, so as I said you, the very common example of pair data, that is a pre and post test from the same people or same object. Two match samples, it could be a one-to-one correspondence between each subject in group 1 that is matched pair in group 2. So in this case, another example of pair data is not the same objects. They can be different persons. They can be different things, but they still match each other in one characteristic. For example, here in the slide, I show you brown hair matched subject. So these two these two boys, okay, they are different persons, but they have the same color, brown hair. So it's a one pair. Okay, we are trying to compare one variable. Okay, and we will try to match the data. In this case, the match data is the hair color. Okay, the character is hair color. So the brown hair color, the red hair color, okay, match each other in the color hair, the color of the hair. So the first pair is brown hair color of two persons, and the second pair is a red hair color of two persons. Okay, so they will try to match the data with each other. So this also an example of the paired sample paired data. So you need to recognize this one so that you can use correctly the test. Sometimes in some cases that you may not recognize the pair data and you apply the independent t-test, so the conclusion is not correct if you use not appropriate test. So when will you use a pair t-test? When we can use a pair t-test? Trần Nam Khang, when
Yes.
you can use a pair t-test?
What? I didn't hear. Okay. Can you say the question again?
When can you use a pair t-test? Khang, can you hear me? Khang?
Okay, sorry, teacher. Okay. What?
When can you use a paired t-test?
What? When you spell t-test? Oh.
Khi nào thì em có thể dùng được cái paired t-test? Không hiểu ý à?
Em hiểu ý rồi nhưng mà
Nãy giờ không vào đầu cái gì à?
không, mình đang xem lại.
Để xem lại. Có vẻ như là Khang không nắm được bài đấy nhá. Rất nhiều lần cô hỏi mà cứ hơi ngơ ngác. Trần Lê Nam Khanh.
Yes, we use pair t-test when the data follow the normally distribution.
Okay, what else?
The dependent variable is a ratio variable.
Ratio, only ratio.
Ratio and interval.
Or interval, okay?
Yes. And the last one is the independent variable is matched together.
Yes, they match together. They are paired data. Yes, or it can be repeated measure. Okay. So before you want to use a pair t-test, you need to check this assumption first. Okay, to see if it's correct test for you. That is the normal distribution. Okay, so for using the t-test, you always need to assume that your data, your dependent variable need to follow the normal distribution. The second is the dependent variable. It needs to be a ratio or interval scale. Okay, if it's normal or ordinal, it could not use t-test. And the third one is a case for paired data. Okay, if you want to use a paired t-test, your data needs to be matched each other. They can be repeated measure, or they need to make paired. Okay, different pairs of data. If not, you cannot use the parity test. Okay, so you need to think about the independent t-test. They are independent samples. Okay. So the assumption for the parity test, that is the paired samples, and the difference of the pairs follow a normal distribution, or the number of pairs is large. Okay, so for using the parity test, you should check the normal distribution, and the normal distribution in this case, that is the difference between the pairs. As I showed you on the previous slide, you will work on the data D1, D2 until the end. Okay, D here is the difference in each pair. You will find the difference in each pair, and you will get a new data set that is a D1 until the end. And you need to check the normal distribution from D1 of the new data set D1, D2, D3, and Dn, if it follows the normal distribution. Okay, and in the case that the number of the data, or they say the sample size n, is large. How large? It is higher than 30. Okay, when the sample size is higher than 30, you can assume it follows the normal distribution too. So you should pay attention about that. When the sample size is large enough, higher than 30, you can also assume that your data in the pair sample t-test, the difference between each pair follows the normal distribution. Okay. And then you need to write out the hypothesis correctly. Based on the question, what do they ask you? You will write down. What we conclude is SA. SA is exactly what we want to conclude. So SA, it could be MIDI. What is a MIDI here? Can you guess? Nguyễn Thị Linh, what is a MIDI?
MIDI is the mean of the difference between the two samples.
Yes, that's correct. D is the difference, right? The data set you are working on the data set of the difference between the two samples, the different pairs of data, and MIDI is a mean. From that data set, you will calculate the mean, okay? And we are going to compare this mean different from 0 or not. The difference different from 0 or not, so we can conclude that the two samples will be different from each other or not. Okay, so based on the question, the MIDI could be different from 0, or MIDI less than 0, or MIDI higher than 0. It's based on what we want to conclude. If MIDI different from 0, what does it mean? Phạm Ngọc Hà. Trịnh Sao Mai. Trịnh Sao Mai.
Yes.
So when MIDI is different from 0, what does it mean?
MIDI different from 0 is mean the like the.
It's what question can be asked for this?
Our conclusion is the difference between each pair is different.
So interpret more. The difference between each pair is different from 0. What does it mean?
So I think maybe the difference each pair is not the same. They are different from each other.
Different from each other? Is it correct to say that?
Just because it's different, it differs from 0.
Yeah,
From
different from zero.
it means that the each D will differ, like D1 differ from D2 and D differ
Yeah.
from D3, like that.
It means the sample ones in each pair, okay, the data in sample 1 different from the data of sample 2, right? The two groups, we are going to compare two groups, okay, and the data are match each other, and MIDI is the mean of the difference. MIDI different from 0, it means the difference between each pair is different from 0. So it means the data in group 1 is different from group 2. Or the two groups are different. Okay? In this case, we conclude that these two groups, the mean of two groups, are different. Okay? That is what we can conclude. So if SA MIDI less than 0, so what can we conclude? MIDI less than 0. Lê Thị Tuyết, Trần Tuyết Mai.
Yes.
So in case MIDI less than 0, what can we conclude?
I think that the conclusion is the difference of group the group 1 is smaller than group 2.
Yeah, so just the mean of group 1 less than group 2. Yes. Right. Yes. So first case MIDI different from 0, we just can say that the two groups are different. But in case MIDI less than 0, we can conclude that group 1 is lower than group 2. Yes, it's correct. So in case MIDI higher than 0, Đỗ Bích Ngọc.
It means that the data from the group 1 is rather than group 2.
Yeah, the data of group 1 is higher than group 2. So is one tail or two tails?
I think it's one tail.
Okay, yeah, it's one tail. So the case MIDI less than 0 or MIDI higher than 0 is one tail test. Okay, and MIDI different from 0, that is the case for two tails. Okay, so you can see that the two tail test, it just gives you the conclusion that the two groups are different. But the one tail test, it can help you to compare which one is bigger. Not only different, but it can show you which one is bigger than the other. That is the difference between one tail and two tail. Okay, the one tail test not only tell you that the two groups are different, but it can also show you that which one is bigger than the other. But in two tails test, it just show you that the two groups are different. That's all. We don't know which one is bigger than the other. Okay, so that is a difference. Yeah, so in parity test, you know that we will work on the data set of D1, D2 until the end. So when you do this kind of exercise, you have to calculate D1, D2 until the end to get the data, and then you will work on this data set. And you will calculate the t-value, okay? For parity test, the t-value formula is a bit different. Look here, it looks simpler than the independent sample t-test, and you take note this formula to do exercise. And the software, they use this the same, okay? The software do exactly what you are doing, but they help you to do it, so you don't need to use your hands or calculator. They did it all But this is the way that the software works. And now you are like a software, okay? You do when you understand what you are doing. So the t-value for the pair t-test is equal d bar. What is the d bar here mean? Over SD over square root of n. What is SD? Bùi Bích Ngọc.
Yes, the D bar is the mean of differences between two samples.
Between the pair, yes, pair data, yes.
And the SD is standard deviation of the differences.
What is n?
The n is the number of the n is the number.
What is n?
I don't remember the
You don't remember the number of pairs data or the sample size?
Yes.
The sample size, yes. And we use the what table of statistic we use?
The table.
We need to use a table of statistics to find the critical value, exactly the same that we have done. Okay, so what table? I send you table. Okay, so what table do you use? What table show you the t-value, the t-critical value?
The table E.
Yeah, table E, okay? And with the degree of freedom, here is n minus 1. What is the degree of freedom in the independent t-test?
I'm sorry, I don't remember.
You forgot it. Hồ Bích Nguyệt, Hồ Minh Nguyệt.
In the T table, in the T alpha, we use the degree of freedom is n minus 1.
Yes, but how about independent t-test?
Independent t-test will the n minus 2.
N minus 2?
Independent t-test.
N. What is n in independent t-test?
N is the sum of the sample size of two samples.
Okay, yes. If you say this, we will say n1 plus n2, okay?
Yes.
Minus 2 in independent sample t-test, okay? And in the pair t-test, that is n minus 1. Okay, so remember that. Okay, you may confuse with it and it can make the wrong result for you. Okay, and so for this test, we do exactly the same like an independent t-test, but thus the difference in the calculating the t-value. Okay, but for t-critical, it's the same. For inferring that is one tail or two tail, it's the same. Okay, and you will have to find out the redirection region and non-redirection region. It's the same, and you can draw the curve as we have done in the example, and to show the t-value, the t calculated is in the redirection region or non-redirection region. And we have the confidence interval too. And here is the confidence interval for the pair t-test. You can take note this equation for the confidence interval. Okay, you take notice, and then we have an exercise. Okay, you do the exercise. So first of all, you need to explain. Okay, it's the difference. So it means you need to explain it is a independent sample or paired sample.
Yes. This example is a pair sample because the data is calculated as pair, is measured as pair.
Oh, it's a bit difficult to hear you.
I'm sorry, can you hear me?
Yeah, but just the microphone is some.
Yes.
Nguyễn Văn Giang, can you do it? Nguyễn Văn Giang.
Chờ em tí.
Nguyễn Văn Giang.
Cô nghe được. Alo.
Hello. You cannot talk. Văn Giang. Đỗ Đoàn Thu Giang.
I'm not finished.
You're not finished? Only Văn Anh, okay. The other. Phạm Ngọc Hà, did you finish? Phạm Ngọc Hà. Phạm Ngọc Hà.
Oh, sorry, I'm still in my calculation. I'm not finished yet.
Okay, so you need more time. Trần Nam Khang.
Still calculate.
You calculate. Okay, time is going out. Okay, so I think you can continue this exercise at home, okay? So next time I will call some of you to describe me, okay? I think that you all need more time. You agree with that?
Yes.
Yes.
Okay.
Yes, so in next lesson, at the beginning, I will call some of you to describe the solution of this exercise. Okay, so see you next time.
Yes.
Okay.
See you next time.
Okay, I'll see you.